Hey there, Accelerated Math. I'm going to talk about which one is better, cheaper, faster kind of unit rate problems today. These are pretty common unit rate questions you see, so I thought we'd walk through a few and make sure you understand how they work. So please label your next page in your math notebook as such. After you have, close the math notebook with your pencil marking the page and concentrate along with me. Alright, let's do a quick unit rate review problem just to kind of spin back to where we were before. So this was kind of a typical unit rate problem we did before. At a charity bike race, I biked 55 miles in 3 hours. What was my speed in miles per hour? So I'm going to just solve that with one strategy. I think I'm just going to do a proportion of 55 miles in 3 hours is the same as how many miles per hour. That means in 1 hour, and 1 means a unit rate. Kind of a ratio of 1. So how many miles in 1 hour was my speed? So looking at that, to get my denominators, change colors. Looks like I'm dividing by 3 here. So I'm going to go ahead and divide by 3 here. And 55 divided by 3 is a long decimal. So sometimes decimals, I don't think a lot of these have come up yet. A lot of times decimals kind of go on and on and on and on forever. If that's the case, we can just cut it off at the 10th place or the 100th place for the time being and kind of say close enough. So I'm going to say at this event I went 18 and 33 hundredths miles per hour. If you really want to get fancy, when you see a decimal go on and on and on and on like that, how a real mathematician would write it is they would do this. They would say, and 3 repeating. That line over the 3 means 3 forever and ever and ever and ever and ever. You don't have to do that. You can just write that or that or that. Round it to any nearest place that makes sense. So we'll just kind of stick with that speed for me right now. I was going 18 and 3/10 miles per hour. So I'm going to take that same question into our I do. So at that race, I went 55 miles in 3 hours, and that was the same as 18 and 3/10 miles in 1 hour. So at another charity bike ride next weekend, I completed 71 miles in 4 hours. More miles, more hours. So at which ride did I go faster? So this is a really common unit rate question. They're going to say, find the unit rate in my first ride, find the unit rate in my second ride, and compare the two and see which one was better. So at my second ride, I went 71 miles in 4 hours. It's not immediately obvious to me if it's faster to go 55 in 3 hours, or if I go 1 more hour, I went more miles in more hours. It's not immediately obvious to me which one of these is faster, because they seem kind of close. So the only way to compare the two and see which one was faster, this one was this fast, is to get down to a unit rate and see, well, here I did 1 hour, I did this. Let's find my unit rate over here. How many in 1 hour? So I'm dividing by 4 here. So I need to divide by 4 in my numerator. 71 divided by 4 is 17 and 75 hundredths. So over here, I went 17 and 75 hundredths miles each hour. So it looks like over here I went a little bit faster. I went more than 18 miles each hour over here. And I went a little less than 18 miles each hour over here. So I was faster here each hour and slower here each hour. Though it was pretty close. It was like around 18 miles an hour at both of them. So that's how a better, faster, cheaper kind of problem works. we're going to find 2 different unit rates and see which one's better. For our we do, go ahead and open your math notebook. For our we do, we're going to do a money one. Those are another common, which is cheaper, is another common, like, compare the unit rate problems kind of thing. So, Aldi sells those little chip bags for lunches, no Doritos, in packages of 24 for $10. Publix sells them in packages of 18 for $6. Who's offering the better deal? So I'm going to try to find the better deal. It's not totally obvious to me. You know, this is like some bags for some money. This is more bags for more money. I'm going to see which place is offering me a better price per little bag. We're going to check Aldi, and we're going to check Publix. So at Aldi, I can get 24 bags for $10. And I want to know one bag, how many, you know, what am I getting one bag for? One bag is how many dollars? So here I am dividing by 24. So down here I will divide by 24. And 10 divided by 24 is about 42, a little more than 41 cents a bag. More than 41 cents a bag, less than 42 cents a bag. So I'll go ahead and round up and just say 42 cents for each bag. Not a bad price. That's from Aldi. Let's check Publix here. Publix is offering 18 bags, fewer bags, for $6. Fewer bags, less money. So they're offering one bag for how much money? So here I'm dividing by 18. So here I've got to divide by 18. And 6 divided by 18 is 30, more than 33 cents a bag, less than 34 cents a bag. So I'll round it down since it was closer to 33. So they're offering it for only 33 cents for each bag. And so I'm getting a better deal here. Each individual bag is cheaper at Publix, even though they're selling me fewer. Each bag is cheaper, so I'm getting a better deal there. That's kind of how better, faster, cheaper kind of problems work. So after you feel like you understand the 2 examples we did, you are done, and we will practice a few more tomorrow when you get here. See you then.